reminders. Something which is from basics to advanced I will discuss. Basics to advanced. Basics to advanced level I will discuss. Basics to advanced level. What are the concepts which I am going to discuss? One is a negative reminder. One is negative reminders. We will see the drawback. What is the demerit of a negative reminder? Then we will see Euler theorem application. Euler theorem application. Euler theorem is used when the denominator it is a composite number. What if the denominator it is a prime number? Then we also will see Fermat theorem application. Fermat theorem application. What if Euler theorem fails? Then we will also see Chinese remainder theorem. Chinese remainder theorem. Totally, I think 2 sessions are required to complete it. Let us see how many problems we can complete. Euler theorem is used when the denominator is a composite number. Certain problems Euler theorem will not give the answer fast. Then we will use Chinese remainder theorem. Chinese remainder theorem is like a digital sum. It will eliminate incorrect answer options. It will eliminate incorrect answer options. It will eliminate incorrect answer options. Chinese remainder theorem. By knowing this theorem, you can solve a lot of problems by eliminating answer options. Next one. Next important key point. Problems based on a power n plus or minus b power n. A power n plus or minus b power n. Last concept is Wilson's theorem. Wilson's theorem. Wilson's theorem. And any other advanced problems. This will be the classroom structure. Any other advanced problems. Any other advanced problems. Reminders is an extremely important topic. Very, very important topic. Reminders. These are the subtopics in reminder topics. The first subtopic is problems based on negative reminder. What is a positive reminder? What is a negative reminder? When to use positive reminder? When to use negative reminder? What is congruence modulo theorem? For powers, for 2 powers, 3 powers. What is the drawback of Euler's theorem? What is the drawback of negative reminder theorem? Why Euler theorem came into picture? What if the denominator it is a prime number? Denominator it is a prime number. Either a Fermat theorem is used or Wilson's theorem is used. Wilson's theorem. How to eliminate incorrect answer options? By using Chinese remainder theorem. Then we will see problems based on a power n plus or minus b power n. These are the 6 types which we are going to discuss. Sure, definitely minimum 4 hours is required to discuss every concept in detail. Let us see the type 1. Type 1. Type 1. Introduction to. Introduction to. Introduction to. Reminders. Just write down in the same sequential order. Introduction to. Reminders. Introduction to. Introduction to reminders. Now, what is a reminder? What is a dividend? What is a quotient? Let us see one by one. One by one. Introduction to reminders. Introduction to reminders. Suppose, see here, sir. 13 is there. 13 is a number. 13 is getting divided by 5. 13 is getting divided by 5. 5 2s are 10. 5 2s are 10. Remainder, it is nothing but 3. What is left over after you divide 13 by 5? 5 2s are 10. Remainder, it is nothing but 3. 3 is nothing but the remainder. 3 is nothing but the remainder. 3 is nothing but the remainder. First we will write some important key points. What do you mean by dividend? What do you mean by divisor? What do you mean by quotient? Quotient. And What do you mean by remainder? These are the 4 important key points that you should know whenever you are solving remainder based problems. What do you mean by dividend? What do you mean by divisor? What do you mean by quotient and remainder? Dividend. What do you mean by dividend? Dividend is nothing but the number which is getting divided. Number which is getting divided. For which number you are dividing? Number which is getting divided. Here dividend is nothing but 13. Dividend is nothing but 13. What do you mean by divisor? Divisor is the number which is dividing. Number which is dividing. Number which is dividing quotient. Number which is dividing dividend is called the divisor, which is nothing but 5. How many times a divisor will divide? How many times divisor divides? How many times divisor divides dividend? That is nothing but quotient. That is nothing but quotient. Remainder is nothing but derived from remaining, which is nothing but leftover. How much is leftover? Take a number, whatever the number that you take, that is nothing but the dividend. Divide this number by some random number. If you divide it by some random number, I will get 5. How many times it is dividing? 5 2s are 10. What is leftover? Leftover is nothing but the remainder. First key point, 13 is nothing but 5 into 2 plus 3. 13 is nothing but 5 into 2 plus 3. Very, very important key point. Dividend equivalent to divisor into quotient. Plus remainder. If divisor and quotient are given, dividend is given by divisor into quotient plus remainder. Dividend is nothing but divisor into quotient plus remainder. Dividend equivalent to divisor into quotient plus remainder. Our entire problems, whatever we are going to solve, we are going to focus on this concept. In the divisibility theorem, we will attack this. This is, in mathematics, is represented by 13 is divided by 5. 5 2s are 10. Quotient we will not write. Remainder is nothing but 3. 13 when divided by 5. 5 2s are 10. Remainder it is nothing but 3. R is nothing but the remainder. 13 is the dividend. 5 is nothing but the divisor. 5 2s are 10. What is the positive remainder? 3. Remainder is written on the right hand side. This is the definition of a dividend, divisor and quotient. This is the definition of dividend, divisor and quotient. Dividend, divisor and quotient. Dividend, divisor and quotient. Next one, dividend, divisor and quotient. Second important key point, negative remainder concept. Negative remainder concept. Negative remainder concept. Very, very important concept. At the end of the class, you will solve close to 60 to 70 problems. First one, remainder 1. 13 is divided by 7. 13 is divided by 7. 13 divided by 7. 7 1s are 7. 7 1s are 7. Positive remainder is nothing but 6. 7 1s are 7. What is left over? That is nothing but 6. Negative remainder is, take a number which is just a multiple of 7 greater than 13. 7 2s are 14. 13 is 1 less than 14. 13 is 1 less than 14. So it is minus 1. One more example. As many examples as possible, we will try to solve. Second example, 23 divided by 5. 23 divided by 5. 23 divided by 5. Positive remainder. 5 fours are 20. What is left over? It is nothing but 3. Just take a number which is just greater than 23. 5 fives are 25. What is the negative remainder? Negative remainder, it is nothing but minus 2. 23 is, what do you mean by minus 2? 23 is just 2 less than 25. 2 less than. Therefore, it is minus 2. 7 twos are 14. 7 twos are 14. 13 is just 1 less than 14. So, it is nothing but minus 1. It is nothing but minus 1. Again, I am repeating it. 7 ones are 7. Positive remainder 6. Negative remainder minus 1. 5 fours are 20. Positive remainder 3. Negative remainder minus 2. Now, these are nothing but these. 13 is the number which is getting divided. So, it is a dividend. 7 is the number which is dividing. So, it is nothing but divisor. 7 is the divisor. 7 is nothing but the divisor. 7 ones are 7. Positive remainder 6. Negative remainder minus 1. Third concept is very important. In case if you got negative remainder, add with divisor. Add with divisor to get positive remainder. Add with divisor to get positive remainder. Add with divisor to get positive remainder. For example, you got minus 1 here. You got negative remainder, but I want a positive remainder. Add with the denominator. What is 7 minus 1? 7 minus 1 is nothing but 6. How to convert a negative remainder to a positive remainder? In case if you got negative remainder, minus 2, add with the divisor to get the positive remainder. If you got a negative remainder, 5 minus 2, it is nothing but 3. Positive remainder, it is nothing but 3. Positive remainder, it is nothing but 3. Suppose in case if you got positive remainder, subtract from divisor. Subtract from divisor to get negative remainder. Subtract from divisor to get negative remainder. For example, very, very important concept. You should know when to use positive remainder and when to use a negative remainder. Suppose you got negative remainder to positive, add with the denominator. 7 minus 1 is 6. If you got a negative remainder, add with the denominator to get the positive remainder. From negative remainder to positive remainder, add with the denominator. Negative remainder to positive remainder, add with the denominator. From positive remainder to negative remainder, subtract it. What is 6 minus 7? It is minus 1. What is 3 minus 5? It is minus 2. Negative remainder to positive remainder, add with the divisor. Positive remainder to negative remainder, subtract it from the denominator. Negative remainder to positive remainder, add with the denominator. This is extremely important concept. How to do negative remainder? What is a negative remainder? What is a positive remainder? How to convert negative remainder to positive remainder in